Hello friends, I'm Pavitra. Welcome to another session of Leibnitz Rule. So in this session, we'll solve some more problems on Leibnitz Rule. So in the last session, I told you Leibniz Rule is finding the nth derivative of product of two functions. So this is the Leibniz Rule formula. Then you have to remember these NC1, NC2 and NC3 formulas. Okay. So in this session, I have considered two problems. So the first problem is if y is equal to this, then you need to prove the result. Okay. So write the solution. So consider the given function. So that is y is equal to given y is equal to sine hyperbolic inverse x divided by root of 1 plus x square, right? So now you have to differentiate two times. So here what I will do, instead of applying u by v formula, so I will cross multiply it and apply the u into product rule. So therefore that is root of 1 plus x square into y is equal to sine hyperbolic inverse x. So now apply the product rule, differentiating with respect to x, apply the product rule here. So root of 1 plus x square as it is, differentiation of y with respect to x is y1 plus y as it is, differentiation of root of 1 plus x square. Use the chain rule here. So differentiation of root is 1 divided by 2 root. So the function is 1 plus x square into differentiation of 1 plus x square is 2x. So that is equal to, now differentiation of sine hyperbolic inverse x is 1 divided by root of 1 plus x square. So now this two get cancelled. Now here you take the LCM. So root of 1 plus x square is the LCM. So that is root of 1 plus x square is LCM here. Now multiply. So root of 1 plus x square into root of 1 plus x square is 1 plus x square into y1 plus, if I multiply here, so root of 1 plus x square, root of 1 plus x square get cancelled. So that is x into y. So that is equal to 1 divided by root of 1 plus x square. So this root of 1 plus x square, root of 1 plus x square get cancelled. So now you will get 1 plus x square, 1 plus x square into y1 plus x into y is equal to 1. So now you need to differentiate one more time. So here also use the product rule. 1 plus x square as it is, differentiation of y1 is y2 plus y1 as it is, differentiation of 1 plus x square is 2x, right? Then plus second term x into y, here also product rule. X as it is, differentiation of y is y1 plus y as it is, differentiation of x is 1. So that is equal to differentiation of 1, that is constant, that is equal to 0. So now simplify this. 1 plus x square into y2 plus here 2x into y1 plus x into y1 is 3x into y1 plus y is equal to 0. Right. So now apply the nth derivative. So that is 1 plus x square into y2, the nth derivative, plus 3x into y1, the nth derivative, plus y, the nth derivative. So that is equal to 0. So now here apply the Leibniz rule. So product rule, apply the Leibniz rule. The first function, that is u, that is 1 plus x square as it is, nth derivative of y2 is yn plus 2 plus nc1 is n, first derivative of 1 plus x square is 2x, n minus 1th derivative of y2 is yn plus 1 plus nc2 is n into n minus 1 divided by 2 factorial is 2. Differentiation, next differentiation of 1 plus x square is 2. Then n minus 1th derivative of n minus 2th derivative of y2 is yn, right? So the next differentiation of 2 becomes 0. So therefore all the terms becomes 0. Now the second term. So 3x into y1. So first 3x as it is, nth derivative of y1 is yn plus 1 plus nc1 is n. Differentiation of 3x is 3. N minus 1th derivative of y1 is yn, right? Plus next nth derivative of y is yn. So that is equal to 0. So now simplify this term. 1 plus x square into yn plus 2 plus now n plus 1th term. So this is n plus 1th term and this is n plus 1th term. Here x into yn plus 1, x into yn plus 1 is common. So in the first term it remains 2 into n plus in the second term 3 remains in plus 3. So x into yn plus 1 I have taken it as a common. Then plus here 2 get cancelled. So this is yn term and this is yn term and this is yn term. In the all the terms yn is common. So if I take yn common, n into n is n square minus n into 1 is minus n, right? Yn is common I have taken plus 3n is left in this next term plus 1 into yn. So that is equal to 0. So now simplify this again. 1 plus x square into yn plus 2 plus 2n plus 3x into yn plus 1 plus here n square plus 3n minus 2 minus n is plus 2n plus 1 into yn is equal to 0. So n square plus 2n plus 1, this is n plus 1 whole square, right? So therefore write that term. So therefore that is equal to 1 plus x square into yn plus 2 plus 2n plus 3 x into yn plus 1. So n square plus 2n plus 1 is n plus 1 whole square into yn. So that is equal to 0. So this result is same as whatever they have given in the exam, given in the problem. So 1 plus x square into yn plus 2 plus 2n plus 3 x into yn plus 1 plus n plus 1 whole square into yn is equal to 0. So this is the solution. So we'll consider one more problem here. So the next second problem I have considered here is if y is equal to this, then you have to prove the first result and the second result. So consider solution. Consider the given function. So the given y is equal to e to the power of m into cos inverse x, right? So now differentiate the function with respect to x. So differentiating, so differentiation of y is y1. Now differentiation of e to the power of m into cos inverse x. Use the chain rule here. You know the differentiation of e to the power of mx is m into e to the power of m cos inverse x, m is constant, into differentiation of cos inverse x is minus 1 divided by root of 1 minus x square, right? So now here you need to cross multiply. So that is root of 1 minus x square into y1 is equal to m into e to the power of m cos inverse x, right? So now again differentiating with respect to x. So differentiating, so use the product rule here. So that is root of 1 minus x square as it is. Differentiation of y1 is y2 plus y1 as it is. Differentiation of root of 1 minus x square, that is 1 divided by root of 1 minus x square into differentiation of 1 minus x square is minus 2x. So that is equal to, again differentiating, m into differentiation of e to the power of mx, m into e to the power of mx, that is m into e to the power of m into cos inverse x into differentiation of cos inverse x is 1 divided by root of 1 minus x square. So that is minus sign, differentiation of cos inverse, that is minus sign. So again already 1 minus sign I have left here. So already 1 minus sign here is there. So therefore minus, I have to write one more time, right? So now, so here, so this is 1 divided by 2 root, right? 1 divided root x differentiation is 1 by 2 root. So this 2 get cancelled. Now take the LCM. So root of 1 minus x square is the LCM. So that is root of 1 minus x square is the LCM. Then multiply this, root of 1 minus x square. Root of 1 minus x square is 1 minus x square into y2 plus x into y1, not plus. Here minus sign is there, so therefore I should write minus, right? So this is minus x into y1. So that is equal to, minus into minus it is plus, m into m is m square, right? M square. E to the power of m into cos inverse x is y divided by root of 1 minus x square. So root of 1 minus x square, root of 1 minus x square get cancelled. So m square into y, you take this side. So you will get 1 minus x square into y2 minus x into y1 minus m square y is equal to 0. So this is the result, first result. Let me check. So that is 1 minus x square into y2 minus x into y1 is equal to m square y. I have taken this side, no problem. So now apply the Leibnitz rule, find the nth derivative. First write the nth derivative. So that is 1 minus x square into y2, the nth derivative, minus x into y1, the nth derivative, minus m square y, the nth derivative, is equal to 0. So here you need to apply the Leibniz rule. So the first term, 1 minus x square as it is, nth derivative of 1 minus x square as it is, nth derivative of y2. So that is yn plus 2 plus nc1 is n. Differentiation of 1 minus x square is minus 2x. n minus 1th derivative of y2 is yn plus 1 plus nc2. nc2 is n into n minus 1 divided by 2 factorial is 2. Second derivative of 1 minus x square. First derivative is minus 2x. Second derivative is minus 2. Then n minus 2th derivative of y2 is yn. The next differentiation of 2 becomes 0. Therefore the terms are 0. Plus, sorry, minus sign is there. You have to write the minus. Here I should write minus. Better you use here one bracket because minus sign is there. Minus, use the bracket. So x as it is, nth derivative of y1 is yn plus 1 plus nc1 is n into n minus differentiation of x is 1. N minus 1th derivative of y1 is, I will write yn here itself, into yn. Okay. minus m square, nth derivative of y is yn. So that is equal to 0. Right. So now you have to simplify this term. So that is 1 minus x square into yn plus 2. Next, plus sign, minus in both the side is there. If you want, I can take common. This is yn plus 1th term, and this is also yn plus 1th term. This is also negative and this is also negative. So therefore I have taken it as a negative also common. And x into yn plus 1, x into yn plus 1 also common. So in the first term it remains 2n. In the second term it is x, that is plus 1 x into yn plus 1. Right. So here 2 get cancelled. This is also negative and this is also negative. All are negative here. So take minus n also common. Minus. Then the first term n into n is n square minus n. So in the next again minus n. So next minus m square. Right. Close the bracket, into yn is equal to 0. Okay, so this is 2n is there, or m square? So this is minus n, I have taken it as a common. So this is will be the plus s. So this will be plus n minus n get cancelled. So now write the equation. So that is 1 minus x square into yn plus 2 minus 2n plus 1 x into yn plus 1 minus n square minus m square into yn is equal to 0. So minus n I have taken it as a common, means it will be a plus. Right. So minus n I have taken it as a common, means it will be a plus here. Okay. So this is the second result. Okay. In the next session I will solve some more problems on the Leibnitz rule itself. Okay. So thank you for watching. Thank you for watching. Please like, share, comment and subscribe to my channel. Thank you. Thank you so much.